Hello, everyone, and welcome to another episode of Observable Flutter. My name is Craig Labenz, and I'm excited about today's episode. I hope you are as well. I'm coming into this with a particular level of ignorance myself, but luckily our guest is, he insists that he's not an expert, but he is at least that relative to me. So we'll see what all we get through today. So the quickest of housekeeping. Remember, folks, this is a Flutter community. We've got a great reputation as this warm, welcoming, friendly community. Where I want us all to live up to that today. Remember, we don't need to dunk on other technologies, other packages, whatnot. We're just here to kind of be excited about Flutter. Okay, so today's guest needs probably not a ton of introduction. Filip was one of the original, actually, I do this all the time. I always try to steal their thunder. Filip, I'm going to let you introduce yourself. And then if you sell yourself short, then I'll talk more. All right. Filip, I'm so excited to have you here today. Would you please introduce yourself?
Thanks for having me, Craig. It's great to see you. And yes, I'll introduce myself as the previous Craig. First of all, I was on the Flutter team doing videos, doing boring, shows and stuff like this. So that's that was for a long time, but until 2 years ago, then I moved back to where I'm now. This is Prague, Czech Republic, and I have been working on some open source stuff. I still do some cool things, I think, for Flutter, like different game toolkits and stuff like this. But my main order of business is making games in Flutter. I have one that I released 2 years ago. That's called Knights of San Francisco with a K. And I also am working on another game right now. So that's my spiel.
Nice. Yeah, that was pretty good. And that second game behind you, you've got there's a big poster advertising it a little bit. Yeah, giant robot game.
Yeah.
I've been enjoying your dev updates.
Thank you.
Obviously they're like half dev, half philosophy. And
Yeah.
that's a wonderful mix.
It's actually I have almost no updates in the past few weeks, because I work on something else. So I'm like, what am I going to talk about now? And I need a pretty decent amount of like existing things like philosophy, so that people understand why I'm doing the kind of game that I'm doing. So thanks for telling me that you enjoy it.
Yeah, no, I absolutely do. Got an immediately funny comment in the chat, but can it run Crisis in terms of us? For those who maybe don't understand this reference, Crisis was just a really, really resource intensive game from, I don't even know exactly when, like 2010 or something.
Yeah, long time ago.
And it was just the game that broke all hardware, and people would say this all the time, like about consoles and gaming PCs and whatnot. But can it run Crisis? That's pretty funny. Okay, so today, Filip, I didn't consult with you on how to name today's stream, but we had, of course, agreed on the content and whatnot. And so when I was like, shoot, I need to make a thumbnail, I just came up with faking 3D graphics, which is probably not a good name. But
yeah, I was going to complain about this actually, because we are not faking anything. This is actual 3D, and I'm sorry, I just jumped into your sentence, but there was
okay.
like, why is this faking? This is not faking. This is actually 3D graphics.
Yeah,
like proper 3D graphics. Yes.
Yeah. So let me sell you on my line of thinking, and then
Okay.
you can either say all right or still boo. Obviously, monitor screens are only 2 dimensions. So in some sense, anything that your brain perceives as 3D graphics is as 3D as anything else, because right, it's all on a screen. But even though what we are going to do is create perspective. The stream name creating perspective might have been a little ambiguous. We are going to add perspective to a cube and explore the math behind that and whatnot. It's different than like loading in and rendering a Blender model or something, which maybe by some definitions is like proper 3D graphics.
Right.
But how...
No, you're right. You're
get
right.
any points
Actually,
back?
on my Discord server, someone made a funny comment. Gylo Smilo. I just that person said, "Oh, Craig probably meant that in the far future we'll have actual 3D graphics, as in like they will be 3D, and instead what we're doing is we're projecting 3D onto a 2D surface, and that's true.
Mm-hmm.
Yes, and also, yeah, we are not going to create a whole render, 3D engine in 2 hours. I expect so. Yes. Okay. I'll allow it. You're faking.
All right. Okay. So I guess let's start. Let's get into it here. So you have added, or you have created a little starter project. And so all the code that is on my screen now and everything until I start typing, which probably won't be for a little bit, Filip wrote recently. And then I'm going to be driving, and Filip will coach all of us through our goals today, which will become more clear once we better explore what we even have to start. So I presume you recently, this was off a fresh Flutter Create, and I'll narrate a little bit and then just cut in at any point. Actually, let's start with PubSpec. I want to see what packages you added.
Yes.
I've not even looked at.
Right. I only added vector math because that's kind of, we'll probably talk a lot about vector math. I'm just going to ask, have you been able to run it?
Oh, yeah, I have it running.
Oh, okay, good. Okay. All right.
It is, and I didn't appreciate what I was looking at here until I clicked on a couple more files, and then I was like, oh, I see what we're doing. So let's take everyone through that. So what we see when we run this as is just 4 dots. And if you, observant viewers at home may notice that this project is called Observable Flutter Cube, not Square. So we're looking at just one side of a cube, it turns out. Well, kind of a 3D rectangle. I don't think it's a perfect cube here, but you let me slide on my definition of faking 3D graphics. I'll let you slide on the size and shape of this cube.
Actually, so this is one thing that we'll need to figure out, and this is actually a cube, but yes, but we somehow need to figure out how to
have it look like one.
How do you make a cube? No, it's okay. So normally, you know what? I'll shut up actually, because when you get to project, we'll understand more why the cube is not actually looking like a cube. Hopefully, will in the future.
Okay. All right. So we've got kind of standard boilerplate here. We're just our scaffold, blah, blah, blah. And then there's an interesting widget here, a view 3D that accepts an object, which is a cube. So first I'm going to look at what the cube is, and then we'll kind of work backwards. Cube, and then I think the thing. So I'm going to click on cube, command click. There we go. All right. So this is an instance of an object 3D class. Did you write this?
Yes.
Class, object 3D?
Yes.
Okay.
It's
I
very
could
simple.
command click that and seen it myself.
Yes.
All right. So yeah, it just has a list of points. Great. And they're in 3D space. So wonderful. And then we look at it here and we can now see, yes, this is in fact a cube because all the sides are of length 1. Do they call that like a unit cube? There's like the unit circle and whatnot. Is this
I think so.
Unit cube? Okay. So definitely a cube, even though it didn't look like that on the screen. So there's some shenanigans afoot. And then we go back to the view 3D widget. which was accepting that cube. And that is also of your authorship. And if we click into that, it's a custom paint very quickly. And then we've got our painter probably down below. Here it is. And so let's see here. You're caching a paint object that is just red. There's some other colors. Some are commented out.
I was just gonna. At first, it was just all red or blue or whatever, but then I realized, oh, it's probably going to not be great when we try to figure out like what the different
which point is where.
Yeah, points. Yes, so it's just going to like iterate through these three colors.
Got it. Okay, so we're not actually uncommenting these is not part of our journey today.
Oh yeah. Oh, that was another thing. Yeah. So I just stole this palette from a website where I go when I want to steal palettes, and they had this amazing palette. And then I realized part of it is too dark, so I just selected the colors that look the best.
Gotcha.
But yeah,
gotcha.
Yeah, okay. You can delete them if you want to.
All right. Well, they're not weighing me down too badly. Right. Looking over at question here or at chat, we do have one pretty interesting question that Randall just asked. Looks like we're defining the vertices but not the edges. What is our implied ordering?
Yes, there is zero ordering. We're going to focus, because we have 2 hours. I thought that we would just like focus on rendering points, which is pretty, I think, after we figure out how to actually see where the points go, then afterwards we can go, oh, okay, so there's like an edge or a triangle between these 3 points, and then you can just fill it. So we're not going to do that, I think, today or ever, but yeah, we're just going to work with points so far.
Yeah, could be a homework assignment for the reader. Yeah,
it's
so as I was asking.
Yes. Good, perfect, Randall. I was actually thinking about like procedurally generating a cube, not a cube, but like a sphere of points, which would like look nicer. But I think we'll start with a cube because it's just nice. Like, I mean, it's easier. It's just 8 points. Yeah.
Yep. Okay, so it just had a little funny mental moment when you said it was 8 points, and I was thinking, wait, I was expecting 9, and then I just pictured like a dice in my head, and like, oh yeah, no, there's only 8.
No, I was also I said 8, and then I was like, am I being stupid? Is it really 8?
It turns out it is 8. Here's 4 and 4 more above. Yeah, I mean, of course, a cube is in some senses 2 2D squares with some z-axis between them. And then you'd only get to 8 points with that. I don't know why we both thought that there might be 9.
Seems like there's gonna be more, but no.
Right. Okay, so that is everything. And then there's this project. Not to be confused with project, English, quite a fun language. Project, where you've got a function here that is going to turn a vector 3 into a vector 2 and project it onto the 2D plane. I'm assuming there's some of your code here that's going to happen. Oh, I appear to have double-clicked on this just in a way to ask macOS to look it up. This function must be incomplete, I'm guessing.
Correct. That's what we're working on, I hope. I think that, well, right now it just discards the Z coordinate and just returns X and Y. Yeah.
So speaking of that, the Z coordinate, I'm guessing, is like into the monitor, right? It's like into this world. And X is the typical left, right. Y is the typical top down. And Z is going to be depth into this universe.
So this is point of contention. If you look at basically any game engine, they all have it differently. So like in some Z is depth, in others Z is up. Then like why is it going there or there? It's just like It's so I'm pretty sure this is yet another way to do it. I think Z is normally up. So we would probably do something like what y equals point.z is probably would be the normal way, and what, but who cares? It's
Right.
yeah, it's a cube. It doesn't matter which point we're looking at. And the other thing that I wanted to talk about, or to cover, is why is the square not a square on the screen? And that's because project returns it returns, if you go back to view 2D and the custom painter there, I
3D
actually
or 2D?
3Ds.
Okay.
Yes.
Did I miss a
And
class?
yeah, go down, and even
wait,
more
yeah,
down. Yeah. See that line 47 and up? It says remaps coordinates from -1 to 1 to 0 to viewport. And so this is like a piece of magic code that you'll also find in all game development, game rendering engines, where where the project or the projection will give you back -1 to 1 for X and -1 to 1 for Y. And then it's your job to just basically say, well, my X is this big and my Y is this big. And so you convert it with this simple math to normal coordinates. So that's why, yeah, if you put it into a square-ish window, it will actually look like a square.
Right.
Right
No,
now.
gosh, that
Yes.
makes sense. Yep.
Yes.
Yeah, I can either give you, I can be a kind host and be like, nice, your square is a square. I'm like, oh, now it's broken this way. We've answered this already, but I think it is worth revisiting. Folks will continue to kind of trickle in. What do you mean faking? Why are we faking 3D graphics? So the quick answer there is just, we're not actually rendering like a Blender model or a thing that is absolutely 100%. No other way to look at it 3D. We're going to add some perspective. We're going to project 3D points onto our 2D screen and create perspective. So a thing will look 3D, and it will be 3D, but it isn't like a 3D model. It isn't 3D graphics in the way that you might think. So that's all I meant by that.
So maybe I don't know, but probably a good point to make is that Flutter is not meant to be a 3D engine, and so, for example, like 3D, like the reason I'm familiar with 3D is that my game has some 3D objects in it, but if I were to make an actual 3D game that has everything in 3D, then I would not probably use Flutter. So like for some very I think interesting use cases, Flutter and Dart are fast enough to just make a 3D engine and use 3D, but please don't use Flutter to recreate like Unreal or anything like this, because it's not going to be a fun experience, and you're not going to go too far, I think.
Yeah. One of the goal, I think everything you just said is totally true, totally correct in my understanding of the universe. My prediction is that in a few years that may change, but it will be largely community driven. I don't think the Flutter team is ever going to be behind changing that. But with Impeller, it is possible that the correct levers will be exposed such that adventurous graphics programmers in the Flutter community will be able to write some pretty advanced stuff, and then we might all build on top of that. But this is in the future, distinctly.
But also, I want to say, it's like, even with something like Impeller, you are probably using like C++ code. You don't know it, but like Impeller is probably mostly built with C++. I don't actually know, but I'm assuming any bigger 3D engine will be built with C++, or you'll be at least touching C++ in some way or another. So in the future, there's definitely a possibility that Flutter will have 3D capabilities, but you're probably not going to build them from scratch. today we're building them from scratch because I think it's interesting, because I think it could be, actually, if I may, I want to present my game just so that people know
You
like
may.
what I'm talking about. Screen one, and see, so like this is the kind of 3D that I am interested in. I'm trying to make things that are um, that are kind of 1970s style 3D, and for that, it's amazing. Like I can do all this, and I can also do things that I wouldn't probably normally be able to do if I was. I want to show you something else than just these, but like notice how if I click, the 3D thing kind of renders from top to down. You see that? Hopefully, this is
Yep. Yep. Yep.
actually pretty hard to do in, or I don't know how I would do it in a normal 3D engine, because you don't have that level of control over which triangles you render. But because I'm building my own 3D engine, or it's done. It's easy for me to do things like this that are kind of like, retro. So anyway, so that I just wanted to show people, like, yes, there are ways, and this runs really smooth. This is fine. But again, if I wanted the game to be completely 3D, then it's a different story, and I'm not using Flutter for that. Cool.
Yep. Yeah. Filip, you got to hurry up, man. Your mission time is ticking down.
Oh, yeah.
Come on, look alive. Yeah, it's it pretty cool effects. And yeah, that really well summarized. That's the goal that we're striving for here, is understanding. Obviously, we're not going to replicate Filip's game, but like understanding how you would begin to build something like this. What knowledge do you need to have? What techniques? And we'll have the hello world of this at the end of the stream. But this is kind of the space that we're in, as opposed to making the next, Call of Duty or something.
Yep. You can. I was just gonna, like, but you can remove me from the. I mean, my game from the stream. Yep. Cool. All right.
Okay. So let's talk through this paint method, because this looks like the most interesting. We already did somewhat here when we were talking about this remap block, but I think this is probably the most interesting code so far. And then, as we mentioned, we're going to doctor up this project method. And I've never appreciated the difference between project and project, and that they're only differentiated by the emphasis in English. I'm going to try to keep getting it right, but even my native speaker brain is taxed by this. So Filip, you and every other non-native English speaker who runs your professional life in English, you just have my respect, because it can't be easy.
Yeah.
Okay. Oh, some new Dart 3 goodness here.
Yeah.
So we've got, you're looping through the objects and the points, and points was in the class, right? Yeah, that's just the list of them.
Yes.
And indexed, is this a thing? Where's this coming from? Oh, this is in Flutter. I've not used this. How new is this?
Is this in Flutter, really? No.
Since 3.0. Wow. Well, no, it says lib collection, so it might not be from Flutter.
It's a collection. Yes. So
here.
This is normal Dart, and it is just if you're too lazy to do a for loop with var I equals 0 to something, and then you can just do this dot indexed, and it will give you a record that has the index and the thing together, which is what I wanted here, because I want the index to select the color, and of course the point to actually see where the point is.
Yeah, I've had written extension methods that did this before, so I was just really curious about where this came from. And I commented out Flutter material to see if that's, if it was going to be underlined, if that's where you were getting it from. But no, it really is just standard library, essentially.
Yeah.
Great. I've learned something already. Okay, so the circles have a size. Ooh, I wonder if this is going to change as they get further away. Interesting.
I don't think we're. I mean, we could, but yeah,
It'll be a stretch goal.
Yeah, stretch goal.
Okay, and then we project the 3D point onto the screen and get the correct color for it, and then update the paint object to use the correct color. And then, as we already talked about, you map it to the to the aspect ratio of the screen and draw it. Yeah. All right. Anything else before we start typing?
I think that's it. So actually, yeah, let me actually kind of sell you linear algebra right now, because I felt we're going to, in the end, this is going to be a pretty simple, hopefully, pretty simple linear algebra thing. And vector math, the package that we are already importing, already has classes for vector, but also for matrix. And it has classes even for projection and for multiplication. You can multiply matrices with vectors and so on and so forth. So it's all pretty, like, hopefully there's not going to be too much code, but we'll see. Of course, the devil is in the details. The thing is that the story here is that when I was a young boy,
whippersnapper.
Young whippersnapper is the correct thank you word. I wanted to be a game developer, and for a while, and so I started building games by myself. This was the 90s, so this was before like YouTube and Stack Overflow and even Google, maybe, I don't know. But anyway, I was young. Yeah, things were different, and and I remember to this day that I had this problem. I didn't do 3D math, but I tried to do 2D math with, like, I needed to rotate something, right, in my game. I don't remember what it was. It could be like, a spaceship or a ball. Yep. I don't know. But I kind of had to figure it out myself. And so I just like had graph paper, and then I would be like, oh, this point, and then I want to move it by 30 degrees to the left around this, rotate and so on and so forth. And then I did like, oh, I know what sine and cosine is. So I tried to figure it out. And then I failed. I was just I just couldn't do it. I figured it out for like going from right to left. And then I was like, oh, great. And then I tried it on the other side and just like stopped working. It's just like, and I just quit, because back then, really, there was no, like, I couldn't just go, like, give up.
No to ask.
There was no one to ask. So I just gave up. So just like to give you the kind of the idea of like, just think about it. Like, you have a point, there's another point, and then like, how do you do it that point goes there? It's going to have some sign and like some trigonometry inside this, right? But it's not immediately obvious. And then much later, I mean, not actually much later, in university, I learned about linear algebra and about the fact that you can have a bunch of like something like a rotation can be expressed with just one matrix, which is just a bunch of numbers, and that's it, right? And then you just apply it, like you multiply the vector with this one piece of numbers, I mean, bag of numbers, and that's it. And it always works. And it's just infuriating that it's so simple in the end. But of course, you have to get there and so on and so forth. So actually, I may present again from my computer. So this is linear algebra. I just wanted to show you, if I tell you linear algebra and you see something like this, if you're like me, you're probably going to be a little intimidated, But in fact, all that linear algebra is, I'm going to simplify a lot. Okay, so if there's mathematicians or people who actually know linear algebra, they're going to scream into their into their like pillows. What? But basically, vectors. So linear algebra is like when you have a bunch of numbers and you combine them. Okay, and so you have vectors, which is something like this, and that's just basically points, for example, in 3D space. It's or 2D space or 16D space. You don't care. And then there are these matrices which are also like bags of numbers. They are somehow they they are sorted in some way, but what it really is just numbers in rows and columns. That's it. And then you have ways to combine these things together, and like, for example, multiplying. And that's just like, oh, you take, for example, multiplying this and this would be like, take this number and multiply it with this number, and then take, I think, this number and multiply it with, I don't remember, but it's just linear algebra anyway. And then by itself it seems just overly complicated way to put some multiplication and addition together. But then you have things like the transformation matrix, which is what we're going to do today, and which also, by the way, you will find in Flutter itself, vanilla Flutter. We'll get to that. But transformation matrix is again just a matrix, right? Like this one, just a bunch of numbers, or this one more generally. And this thing, if you take a vector, which is just a point, and you multiply it with a transformation matrix, so just a special bunch of numbers, you will get different effects. So, for example, here is how you do stretching. So if like zooming, basically, right? So you have a 2D point and you multiply it with this matrix, and then you get the point is now bigger, right? So that's what transformation matrices do. And the cool thing about this, another cool thing about this, is that you can combine transformation matrices together just by multiplying them. So you have a stretching transformation matrix, and I don't know, rotation transformation matrix. By the way, this is what I quit about. Okay, this is the thing that took me a day of my
That's
life.
what broke you.
yes, and see how it's easy. Anyway, so if you combine this guy with this guy, you suddenly have a stretching rotation matrix. And this is where we go to something like Flutter, where if you probably know the, where should I put it? Transform widget, right?
Yep.
And you have things like, oh, transform rotate and blah, blah, blah. Well, guess what? It's
I'm not
all
prepared to make this guess.
This is all just matrix 4. Isn't it crazy? Transform, whatever you do with transformation is going to be I thought there is a matrix part of it, or is it just this one?
Yeah, do you pass in? Yeah, because the transform.
Yeah.
Pass in,
Yes. Okay, so
but nobody uses this because then you have to know the matrix yourself.
Yes, exactly. Yes, but the cool thing is that really, like, Flutter is just whenever you do transform rotate, transform scale, or anything like this, it will just take this transformation matrix or it will generate it for you, and then it will apply it. And so it's very fast. It's also like if you want to skew something and then you want to also rotate it, you can also do this. And this is also why, for example, it's possible for you to do, like, the Star Wars scroll that like goes like this,
Mm.
and it's like in perspective. This is,
Yep.
if you know what you're doing, you can do it with transform matrix 4, because again, it's just another transformation matrix that you just have to know how to do it, and that's what we're going to do today, is basically just getting two a transformation matrix and just multiplying all the points with that transformation matrix, and voila, we have a rendering engine, beginnings of a rendering engine.
Dang, what a primer. My history with linear algebra is one of just, I think, the same frustration that you had. Like, I took a linear algebra class in college, and I hope he never watches this stream, the professor, because I think it was the worst professor I ever had in my life. And I would just really soured on the topic. And, linear algebra, all the operations felt like, if it was cooking, it would be like, take a cucumber, juggle 2 eggs, look out the window, and now you have a pie. And it was just like, how did this work? What are you talking about? And I understood nothing that was going on underneath those operations. It's like, I can remember this by this, by this, by this, by this, but I don't understand any of it.
Same here, by the way. I went to university, we did the linear algebra, and I was just like, I remember I was pretty good at like the computation part when I knew where to actually go and like how to do this. But nobody told me that this is so cool. Like, if someone told me, hey, and by the way, you can just do like rotations with this, and this is how easy it is, then I think I would I would be more motivated to actually like look at it more than just like, it's another math thing that you have to do. But it's very useful, and it's going to be the basis of our work today.
My screen share went away. I would think it's just times out. I'll have to share my screen again here. Clicking around. I am clicking. There we go. All right. And this is all going to happen, in the project method.
Yes.
All right. Now, I'm wondering if we're going to also add some parameters. Obviously, we're going to have to add some parameter unless we hard code the transformation matrix in here, but then this can only project it in one way.
Yes, correct. Yes, very good. Yes, and I think for now we'll just hard code it, and then we can always give it as an argument.
Okay, I love it. Is it time for us to type?
Yep, it's time. I'm afraid we've tried to dodge it for long enough.
Any other philosophy we can cover here? The biography of the people that discovered linear algebra. What their hobbies were. Yeah, it's time. Okay. So I'm typing, but you have to tell me what to type. So I don't know which of us is more hosed here. How do we get started? When did I change?
All right. So I am pretty sure that just start typing make view matrix. Like,
okay.
Yep. See,
wonderful.
This is just, to me, this is crazy. So like this is coming from vector math, and it just takes 3 vectors. One is the camera position, second is the focus, or like the target. So we already know where the target is, I think.
Is that the center of the cube?
Maybe. Yeah, I think so. And then up direction, we just decided, I think we decided on y is up. I'm not sure, but that's going to be a vector. Anyway, let's go back to the code, and camera position. Let's just put it. This will be a vector 3, yes, and it will be probably some space away from where the cube starts at 0, 0, 0. And it doesn't matter where we put the camera because we're going to look at the cube. So
why are we here and not like here? How did we already get this far in? How did this happen?
Oh yeah, I have a padding of 64 pixels, I think.
This is a lot of pixels.
No. Okay, so the yellow one, this is why we have colors. The yellow one is at 0, 0, 0. And no, not this one. The one in the center. Yes. So we are currently just we have it set up because in the end, hopefully, all the different transformations will give us an actual -1 to 1, but with all the things that we need to have there. And
so this is the origin. Makes sense.
This is the origin. Either this is the origin or the one after it is the origin, right? So I mean the one beneath the yellow one in the center, you know what I mean? Because all of these 4 red points are actually 2 points on top of each other.
Yep.
Anyway, I don't actually know which one is which, but we'll have to.
Well, we're about to find out once we have perspective.
Yep. Yes.
Okay, so how to think about, and I think this is what you were just saying, this vector 3, the camera position. So yes. I'm gonna use my hand here to try to illustrate perspective as we're going to visualize it for everyone. And so there's a flat. I'm going to cover my face. I don't know. That's what everyone wants. We've got a flat screen that is the UI. That's the actual monitor, and then the camera is going to. What I think you're saying, Filip, is that we're going to define a space above the screen that is where the math will compute our camera perspective from. Is that correct?
I think that is correct. Yes.
Okay. So we can, what makes sense? Like, should we say the origin in terms of X, Y, but in the depth perspective toward us, or do you like a different point even?
Yeah. Craig, I have no idea. I literally have no idea where to put the camera, and I'm sorry, but
that's okay.
But I think what is the saving grace for us? Yeah, exactly. I would go farther away with the camera, so like 10. Let's do or 5. Okay. Then we have the camera focus position, and that should be, I think, 0, 0, 0, or if you want to be fancy, 0.5, 0.5, 0.5 for like the center of the cube.
Yep.
Oh, fancy. Okay. And the up direction would be probably 0, 1, 0 with Y is up. But again, that should, so it needs to know like how the camera is rotated. Right?
Yeah.
So you have.
So I want to go back to the code and really drive home what all these values mean. So obviously this is X, Y is the second one, and Z is the third. I'm just going to have the most elementary approach to this ever because I'm so bad at all of this. So X is the first parameter, Y and Z, of course. So X is definitely left and right. Y is definitely up and down. And is Z is going to be depth for us? Am I correct on that?
Might be. Yes. I'm also go ahead.
There was also the camera up perspective, and I'm wondering, does what we put here define these values? Like if we said, oh no, up isn't the Y, up is actually X, is that going to like rotate all of our stuff 90 degrees?
Yes.
I guess we can test it and find out.
Yes, we'll definitely do testing, but I think yes, it's basically so like if you want to define a point in space and its rotation in all 3, rotation things. I think one way to do it is to say where it is looking at, assuming of course it's not the same point.
Yeah,
And
it
then
is the camera in this sentence, right?
yes.
So
And
where
then
it is, that's this. Where it's looking.
yes. And then the last one, you still need to, even if you have 2 points in space, you don't know how the camera is like this, right? Is it looking down, or like how the yaw of the camera, I guess. So for that we need to tell it where it's
Oh, could we maybe misconfigure this in such a way that we point the camera in the other direction and don't see anything? Is that
I think
possible?
so. I think that's
Oh,
possible.
I want to do that
We'll
at some point.
okay, yes. So anyway, you want to you made the matrix, you want to put it into a variable, which would be the, I guess, view matrix. Thank you. Yes. And then this is the cool part, where this is kind of the look at matrix, and you just do we don't have the projection matrix yet, but we'll see if we can do it without it. All right. So you have this transform, and then the vector, the 3D vector, has a method on it called dot apply matrix 4. That's it. So if you just do point dot apply matrix 4,
Okay.
and do the view matrix.
And is our view matrix, that is a matrix 4? Yep, that's what it returns.
It is, yes. We're all, yes. All these things are matrix 4. I can't explain it. I don't know enough about this. But if you want to do 3D things, matrix 4 is, so the 4, you need the 4x4 matrix. So that's
do we do this essentially?
Yeah. So I think apply. Oh, is it? I'm not sure if it
modifies
gives you
in place.
It modifies. Yeah. Okay. Yep.
Yeah, returns
Then
void.
yes.
And so then the code that was here before needs to be after what we just added, I'm presuming, and then we do this.
Yes. All right. So hot restart. I think we need to hot restart because for some reason. Oh. Yep.
What were you expecting?
I don't know. I was expecting to not show anything, but this is better than what I was expecting. All right. So that's the view matrix. Now, I think we also need to create another, and that one is the projection matrix. So, and here, this is where I can't really pretend anymore that I understand like the like why you need all of this, right? So but in 3D rendering engines, you have the kind of the object matrix, which allows you to do things like rotate the object, right? Then you have the look at matrix, which is like where you're looking at from, I guess. And then there's the projection matrix, which gives you a just projection, like where do you put it? I don't know. Anyway, for that we can't use the make view matrix. We need to do a final projection matrix. Yep, equals, and now we use make frustum matrix.
Of course.
Yes. All right.
Obviously, it was always going to be that.
So,
all right.
So
frustum,
frustum, if I understand it correctly, is basically kind of the if you look at something through a screen, right? Frustum is the 3D object that goes from this to there. It's like it's like the, I don't know how to call this. It's not a it's not a pyramid, but it's a pyramid without this
with the
part,
top cut off. Yeah. Yep.
Yes. So I think that's what we need. But yeah, hopefully we'll know more if you read the API. dots.
Yeah, so I was
there.
just skimming. Yeah, it says left and right specify the coordinates for the left and right vertical clipping planes.
All right, so that's
And
this
right. Yep.
and this. Yep.
Yep. And they're just doubles. So how do we represent that whole plane as just a double? Do you know what that? How does that work?
Mhm. That's a good question. So,
But I totally had the same opinion or same thought. And then bottom top, specify the coordinates. So same thing, but rotate your hands 90 degrees. And then near and far, specify the coordinates for the near and far clipping plane. So this would be the bottom of the pyramid and where the slice is on the top that prevents it coming
right,
to a single
right,
point.
right.
But how are these
So,
doubles?
yes. So we basically, you know what? I'm going to cheat here, and if you
Great.
look into the private chat that nobody else sees, you can just copy paste. You can copy paste what I just stole from Flutter Cube, by the way, which is the Flutter _cube is a pub package that you can use for these things, and that has the not all of it, not everything that we need, but some of it. And
Okay.
I think it will help us explain what all this is, right? So I don't think you need math with a prefix because we don't have math there. Okay.
I'll just add it.
Yep.
Okay.
All right. So then we the near one is just put something like 0.1 there, like, yes, exactly. Yes. FOV is the field of view, right? So that would be something like 60.
So 60 what? What does that mean?
I hope that's 60 degrees, but that's weird because we're actually converting into radians later. So that's 60 degrees of, so field of view is like for example, humans have, I don't know, 90 degrees or something like this of field of view, but like you have eagles who have a much more focused field of view, and then you have guinea pigs who have field of view like this, where it's all around them, right? So 60 is, I guess, just one possibility.
One possible. Okay.
Right. Zoom can be 1.0, just like, let's not do anything with that. And then aspect ratio, for now, just do 1.0. And I'm pretty sure we'll find the aspect ratio from the size of the screen later, or screen of the custom painter. So I think now we have everything, right? Oh,
we're just missing far.
Let's just put like 1,000 there, or
Got it.
So now we have the first term. We have that object in space, and now, if I remember correctly, I guess we just need to create a new transformation matrix. So another one, final transformation matrix. That's and that is basically just, if you do which one was the first one? The
view matrix.
Yes. Actually, projection matrix times. No. I'm sorry. Just use the ones that we just made. Yes. So
the view matrix times the projection matrix.
Yes. I think the order actually matters, and I think it's the opposite way. But let's see what this gives us. So view matrix times.
That's not what I wanted to do.
View matrix, and now
this is our only transformation matrix.
Yes, exactly. And now use that instead of that, and now let's see what it does for us.
Ooh, the alchemy is getting hot already.
Now I'm very curious what you're gonna. Oh man! All right.
Hard to know if this is what we expected or not.
It's not. I thought that now we'd have some kind of a
Both of
perspective
like the
there.
far side in the middle, right?
Yeah.
So if we have our near for the close 4 dots and then the far 4 dots, I'll do this from the camera's perspective. We've got the close 4 points, and then what we're looking for, I think, is the far 4 points to all be projected inside. Is that
Yes.
that's what
Yes.
you're expecting? Okay.
So, okay, time to just wiggle the numbers.
I love it.
So, not these ones. I think these are fine. But what I
That also
meant
changed
is,
nothing.
yeah, that changed nothing, which is
Oh, wait. No, it did change
no.
something.
Ah,
It just took
okay.
a long time.
And that makes, I don't know why it took a long time, but that makes a lot of sense that now you are like, if you change the field of view, it should be smaller, right? Like if you
Yep.
make the field of view bigger, the things
That
should
makes
be
sense.
smaller.
Yeah, we
So
see
that,
more of the world.
yes. So this part, I think, ooh,
This is collapsed into a singularity.
wow, interesting. Yeah,
Oh.
I think,
So I guess, yeah, that's like the speed of light. You can't exceed 180-degree field of view.
maybe, I don't know. I don't know what any of this means, but I think, yeah, 60 is fine. And let's do, yeah, it needs to be a double. Let's actually wiggle the other numbers, the ones that are in the projection matrix, I think.
Oh, these ones, the view
Yeah.
matrix.
Oh, make view matrix. All right. So what happens if you change the up vector to something like 0.5, 0.50? Or yeah, like, I want to see if we rotate the view of the camera, and we didn't.
I haven't done it yet because I want to propose that we start making predictions about what our code changes will do.
All right.
And some kind of rotation. I mean, I'm just running on your explanation here, but what I'm hearing is, up for the camera. If the camera is now facing a different way, yeah, on our screen, everything should change. So I agree with your prediction this time.
All right, let's see.
We've also changed. It's not a very fast restart here. Things really moved. I don't know why it's being so slow. That's kind of weird. I had also changed the field of view back, so that's why the points expanded as they did,
Right.
but they're now kind of off the screen.
Which is fine. I mean, I think you can change the field of view to something like 90 or 70, so that we always have the thing inside. But this actually makes a lot of sense, right? Because we moved the up to 45 degrees. So if you do something like
I'm thinking we give a non 0.5 value for this, and then things
all
should be
right,
wonky.
yeah, they definitely should.
The hot restart's a little cold this morning.
Yeah, it's weird. It's weird. Okay, it didn't do anything.
Oh yeah, no, I guess that just changed nothing. Really though?
Yep. I guess it makes. I mean, I don't know.
This we said depth. So does changing the in and outness of what's up matter? I mean, you'd think it would. Otherwise, this would be a vector 2.
Yeah, and the thing is, like, if you imagine if you have a camera like this, and then you're like, where is the up for the camera? And then what you did to right now, I think you said the up is not here, but it's here, which doesn't change anything about the camera's position, I think, because you are still looking at that cube.
So looking in that, because that all came from this code.
Yeah.
Is that right?
I'm not sure. I'm not sure. But I think like since the camera is in the Z direction, changing the up position, like the Z direction of the up to position is not going to change the view of the camera. But you know what? I think let's just put it put up to like either 100 or 010, anything but 001. I think it's probably good for it to be a 010, to be a unit vector. And I think this should kind of, this should work. I'm not sure why we see this though. And so I wonder, what does, if you scroll to the bottom of this function, what if we are using the wrong XY? What if the transformation matrix actually, like, can you try Y
Z
equals
here, right?
Yes. I'm not sure. I'm just,
They're gone.
they're gone.
They don't love us anymore.
This was faster for some reason. Okay. So
it's been really inconsistent. Yeah, I don't know.
Okay, so in this case, I think we were right with point, but Y is probably Y. Huh. All right. So
and the reason we tried that, by the way, is you were explaining this to me. I think it was before the stream started, but maybe you already explained it to everyone. Different game engines, different 3D rendering engines disagree on what X, Y, and Z even mean. And so you were wondering if we had a mismatch there, but that didn't fix anything.
Right.
Or if it did, then we've got something else broken.
Right. So we have projection times view, right? And not the other way around.
We do have projection times view, yes.
All right. Okay. I'm just looking at, okay, so the
change that we just made. Now, one thing I was talking about was like pointing the camera in the wrong direction. I'd love to better understand what this means. Or no, is this the wrong? What is the third one? Oh yeah, up direction. I guess I don't know what up direction even means, given that we're positioning the camera with the first two values, and all of this stuff was supposed to be like the cone of, this is almost like the field of view. I mean, we literally have field of view up here.
Right.
And then we changed, some of the up values here changed nothing. I'm definitely not understanding this parameter in terms of, what, if you have a camera and you have some stuff in front of it, like what are we doing with this parameter? I don't know.
Right. Well, we're just saying, if I have a camera like this, and like it's in a position, let's say this is -10, 00 or something, and I'm looking at you, at you, all right? Then the 2 points themselves don't say anything, but then you need some kind of thing to say from here, the vector, where is the vector to the camera's up? So if it's like this, then I'm looking at you like this. If it's like this, it's going to be like this, right?
Okay.
So we can actually, so this is why when we change it to 0.0.0, then we did this basically with the camera, or maybe we did this, I don't know. But we did,
is having a zero vector there almost undefined?
Yeah, I'm pretty sure it would be not good. We could try it. It's not that.
Did we ever put 0 there?
No.
They're back to just 1 point. So yeah, something.
Right.
Okay, well, we don't know if they're 1 point. They could be stacked on top of each other, or
they could be somewhere else. Yes, exactly. So just put the this is fine, I think. I wonder if it would make us understand this better if
Great.
we.
This is what I was expecting. They were going to rotate 45 degrees. Awesome.
Yes.
Thank you. Good explanation.
I wonder if we want to actually write code to rotate the cube so that we um, so that we see what's happening, because right now it's just like these 8 points are taunting us by being in the wrong place, and we want to know what's going on, right? So
We've got some folks in the chat who are really following the plot and seem to have played around with this stuff before. Muaz
yes,
is talking about the camera position being correct, and Hyung Tae says, "Isn't the perspective coming from the 1 in vector 31010?" Yeah, which is both correct and what just clicked for me after Philip's last demo and then that test. Roa had a comment earlier that is really ringing true right now after what you just said made that click as you're like holding your phone and tilting it. Yeah, you got to have graphics and whatnot to learn this kind of crazy math, so you can visualize what these numbers are doing. All right, so what are you thinking for our next test?
so I still don't understand why the perspective doesn't work. I thought that
And that's right, that's why the far. And so which code did you think it was? This whole the projection matrix, right? And the frustum matrix, which is frustrating us.
yes.
That's what was supposed to. Yeah, we call it a projection matrix. That's right. That's the code that is currently not working for us. So I'm going to play around with a few more numbers. So near, this is the top. Is this basically like anything closer than this we can't see?
Yeah. So near is
So-
if you like bump with your camera into something and you no longer want to see that, right? So that I don't think that's the problem that we have, because we literally see all the things that we want to see. They're just not in the
Right.
in perspective. And I think that's what we're missing, is perspective.
So I have an I want to like play with this a little bit too to see if I understand this. So we positioned the camera. That was the first parameter. We positioned it. Okay, go away, tooltip, in the center of the left-right space, and then 10 units away from that. So it's almost like our camera is 10 units off the top of the monitor.
Right.
And we're saying that the near point, so anything closer, we're 10 away, and anything closer than 0.1 gets cut off. So we definitely see everything. If I'm understanding this right, if we put 10 here, in theory, we would lose 4 of these squares, and we would just see the other 4 that are on the other side of the matrix.
Yeah. I would
Is
put
that right?
10.5, but yes,
Be sure.
I think so. Yeah, because it could be just on the frustum.
Right. So I'm running it, no change.
What?
My suspicion grows that your theory of like this code just something ain't right is potentially correct. Top times aspect ratio. Interesting. So this kind of makes sense. We calculate, once we know one of them, we can kind of deduce the other ones. So it makes sense that all these values would only appear in the one calculation. I think that makes sense. But this definitely busted my expectations. I thought we were going to lose 4 of those points. Is it potentially, and we're focusing on the middle of it. I don't think this is going to change anything. And it didn't. All right.
What happens with zoom? Can you zoom in or zoom out, actually? 0.5?
Yeah, so everything should get closer.
0.5 should be smaller, yes.
Yep. Oh yeah, closer to each other, not closer to us.
Oh yeah, yes.
All right, yeah. So that one is working. And we already know field of view is working because we saw that. aspect ratio will I think work. This will have some effect. Should stretch it. Stretched. And so interestingly, it's basically just this near value that, well, we don't know if it's doing nothing, but this change didn't activate any. Let's try let's try 100. That's 1,000, however many zeros I might type. No change again. So near is really not doing anything.
Yeah, it's weird. It's weird. But I don't think that's necessarily, what's our problem, to be honest. We can look at this later. But right now, I wonder if we can just, we don't want to, we don't need to rotate the actual cube. We can just rotate the camera around the cube, I think. And so that means that you have to go back to, I think, 3D view or view 3D. And we need to add what's the fastest way to add animation here? Can you do it quickly, or is it a force? Right.
No, I think we could do it.
Yeah. Okay.
Yeah, we can do it.
So like you probably want to change this view 3D into a stateful widget with a animation, like a repeating animation.
Yeah. So
extend state with.
This is it. Yeah.
Yes.
So we can either use an animation controller, or we could just have an animated container, and we'll just have it do like one thing.
Yep. Sorry, I forgot about that. So you probably don't even need the stateful widget then, right?
Well, potentially we need to get a value out of the animated container, I guess. So actually, I don't know if that would make any sense. Maybe we need our own animation controller.
Okay. Yes. Yes. I like this role. Yes.
Nice. All right. Now here comes the point where I have to Google this every single time.
Oh no! So it's extends with a single ticker container, single ticker provider mixin. Yes.
Vsync this,
and then vsync, and then also not vsicken. That's coming later. That's Flutter 4.0. But I think you need to give it a duration.
Yeah.
And I think that's it.
Okay. And now
start it. Just repeat. Controller repeat.
We need a listener as well.
Oh, that's right. Yes. Well, actually, no. No. Just controller dot repeat, I think, is how you start it. No. Oh yeah. Okay. And now that's the cool part. If you go to the custom painter,
pass it in here.
Yes, custom painter. Actually, actually the painter itself. Nope. The painter itself. If you go to the and if you do on view 3D in the constructor, there's actually the super custom painter itself, the class itself has super dot listenable, I think, or something like this. Yep.
Extends listenable.
Oh, repaint. Yes. So you need to you basically do.
Oh, nice.
Yeah, nice, right? So or super repaint. Yep. Oh, you can just do super repaint. Yeah.
No. And then do I have to do? Wait. Why is it? Why does it not like us? No associate. Oh, yeah. Okay.
Oh.
And now it says is never used. Okay, well, give us a second here, Linter.
So yeah,
we're working on it.
You go up and just do repaint equals the controller.
Oh, I've never done that before.
Yeah, nice. This is really cool. And so now I think you probably have to hot restart or whatever.
But we didn't even tell this to like go from 0 to 1 yet. Does it know to do that on its own?
Yeah, from 0 to 1 is fine. Yes. So now we need to pass the value of the repaint to the project. Sorry. That's a terrible name for that. So yeah,
let's do the correct name.
Yeah. All right.
So this was just repaint.
Repaint, yes. So repaint dot value, I think.
Oh, because it's the whole controller. Makes sense.
Yes. Is it an int?
That's an int. Yeah. We're both like, huh?
That's terrible. What? Why is it an int?
All right, so we're going to add a double to the method
yes.
signature, so it stops complaining about that. And now we can come back and undefined name repaint. Okay, what do you do with that value in the constructor?
Oh, you know what? Okay, so you need to actually create
it's underscore.
Yeah, and so you don't have access to it, but you can.
We can add a listener.
True, but we don't need to do that. So what you need to do is you create your own final field on Vue 3D Painter. That's something like ideally something that is a better name. For example, like
how about that?
Animation. All right, animation, and then assign to that animation. Yep, it's not super. It's like this, and it's required, and then in the initializer list. Oh yes, thank you. So after the constructor, sorry, and then do
like this.
Yes.
You mean?
No. With the colon,
I see. Yep.
Yeah.
Yep.
And
I
then
don't know what it's called either.
Super. How do you do this?
You want to set it to the repaint thing?
Yeah. I think how do you do this? Like,
what's underscore? We can't.
No, but you can. I think you can. You can kind of call the constructor of the superclass,
but still hold on to the value.
You could just like instead of dot, if you put parenthesis, is it possible? But super parenthesis.
Oh.
And then repaint.
Oh.
And then animation.
Oh.
See? Yeah. All right. I'm glad that this worked because I was very unsure. All right.
That's funny. The advent of the super parameters means I haven't actually explicitly called a super constructor in so long. I literally forgot it was a thing.
Yep, it is a thing. So the return of super. So all right. So now we have animation, and that has a value.
It does.
And actually, no. You have it as a listenable. So I think.
Does it need to be animation?
I think it needs to be animation of double. Yes.
Okay.
And now.
No, that's all good. But we have a complaint up top, which is, what are you mad about?
It's late.
Initialized.
It's late final, I think. Indeed. Yep. All right.
Okay.
And now project.
Right. So this has to use its new parameter. And what should we call this to be better than value?
Rotation.
That's much better.
And now let's do some trigonometry. I think what we want to do now is, instead of the make view in the make view matrix call, the vector of where the camera is should be 0, 0 sine rotation, or 0 cosine rotation, sine rotation.
0 cosine rotation. Oh, it's math dot, I think. Yeah. Set myself up for that headache. And then math dot sine rotation.
Yeah. And probably times pi, but we don't care about this now. Let's see what it
let's see what it does. Okay. Refresh.
No.
Okay.
Times 10.
Oh wait, something just. I don't know if it was on the visible on the screen.
Times 10. Times 10.
For both of those, or just the last one?
For both, I think. You can actually times 10 with the whole thing, but it doesn't matter. Okay.
Oh
so
right.
Let's see.
No, well, we will do that because 0 times 10 isn't going to complain. They just flew all over the place. I'm going to extend the duration so they're more visible for everyone. Duration, where are you? Here we go.
Minutes. Oh,
Now it's going to move real slow. What? Wow. Or not at all.
This is amazing. I love it. Okay, so I don't see any perspective. I don't days. Wow.
It's still not slowing down. So, okay, what I think is happening is it's just buzzing by at like
No, I think there's
crazy
some, yeah.
speeds.
Or it's something is weird with our
We have a bug
so
somewhere.
go back. Please go back to 2 seconds because I'm a little worried about that days thing there. And let's go back to here. Why is this?
Oh, it's an interesting idea. Is something in degrees but not radians?
Oh. Yeah, but it's from 0 to 1, right? So I mean, in radian, if it was in degrees, okay. You know what? Put the 0 in the vector somewhere else than it is now. Like yeah. Let's see if that changes anything.
This is really scientific.
Yes,
it did change something. There's nothing on the screen now.
Put the 0 somewhere else now. Yeah. To the last one. Yeah. Okay. Let's just do it. Let's just try different.
Let's just get crazy. Let's just who knows, right? Let's just try it. It didn't do anything.
Still nothing.
Rendered nothing.
Damn it. All right. Okay. So time to do something. ChatGPT in hell. So another thing is just to like. Okay. So we had 0, 0, minus 10 or 10.
For which thing? This value originally?
Yeah, originally.
It was 0, 0, 10.
Okay, so let's just do 0, 0, 10 for now, and let's not use the rotation for now. Yes, and I think you need commas. Yes.
Okay. I won't be cute here because then this might get us later.
Okay.
Okay.
And we still don't see anything? That's weird.
Oh, sorry.
What?
We see things.
What?
Moving in the right direction.
No, but what? Why is it? it's the same thing. Why is it? What? This makes 0 sense. We are not. It's a constant function, right?
Wait. Yeah, we're not using rotation anymore.
Yeah, exactly.
Nothing is changing.
And now it just okay. So one thing that is I actually this is a great thing to talk about, because one thing that throws people, including me, off is that,
including me,
yes, is that in Flutter everything is like declarative and immutable, right? Here things are mutable, so if you change something, it's going to keep changing for other things as well. I'm pretty sure, since we're like, normally this should be a pure function, right? We're just like putting a point. You even, yeah, exactly.
past one.
Yes. So we are changing something like
on accident.
Yes, we're mutating something somewhere, and that's not good. So I don't know what that would be, but man, no, it needs to be in the project method,
it has to be,
right?
But
what are we?
This is a pure
changing?
function.
Oh, I know. I see it now. I see
You
it.
do?
We are applying the matrix to the point, man. We're applying the matrix, so we're changing the object.
Oh my gosh.
Yes,
Why
exactly.
does this not? Why is copy not a thing?
There's
Clone.
clone. Yes.
Yeah.
And
My.
wait. So and now you have to like you're not actually using that now. You're cloning it, applying the matrix to the clone, but you're not. Yeah.
Yep.
Yep, and you probably need something there with like parents because your dot clone dot apply matrix. I think. No.
Wait, sorry. I was expecting this. Okay, so
No.
I'm going to go full screen here again.
No. Yes, thank you. No, you know what you're doing? It's like new point. You need new point dot clone dot apply matrix 4, and you don't need that thing in the. Because you are like apply matrix 4 probably just returns void, so new point was a null.
You're totally right. You're totally right.
Okay, so let's see now. I'm feeling good about this. Cool. Okay, so now we're back in.
I think it said we have an error. Wow.
Is that alt?
An error? Yeah, maybe. But it didn't. No, it still says try again after fixing the above error. It's just, I'm going to do a full thing. It's like real confused here.
Yes. Yeah, so chocolate image says, I think apply matrix 4 doesn't return anything. Exactly. So that was the problem. We had a null thing there. And the cascade operator, we don't need to actually use it. It's kind of a fancy thing. We could just do new point dot clone, and then new point dot apply matrix would probably be a little bit more. Really?
Why is the editor not showing? I didn't save the file. I'm sorry.
Oh,
sorry. All right, what change do we want to make here? Sorry. So point.clone gives us a new point, and then we're cascading to apply.
It's fine. I just like for more readability, I would personally probably remove the cascade and just do new point dot apply matrix 4 on a second line. Just yes. 4. Yes.
One of my least favorite things about StreamYard, though I don't know how they would fix it, is like so often I'll try to click on a chat message right as a new one comes in, and then I click on the one that was below it 100 milliseconds ago. I meant to click on chocolate images thing that was the line you were trying to read, and I clicked on a different message. Okay.
So people are actually save the project file.
Oh,
people are screaming at their monitors like, what? I know folks, like just like I see your frustration. We can see the frustration, and I know how painful it is to see someone like fail so hard, but also I've been there many times where I just did like some stupid things for 30 minutes and people were like screaming. Anyway.
Oh gosh, yes.
Yeah. Let's see where we are now. Oh, cool. So I think now we can reintroduce our animation, which should be pretty easy. Just like, yep. And are you actually putting it in as in the when you're calling project?
Yeah, I put it back in.
You are.
Here we go.
Oh, nice. All right. So are we ready?
Oh.
Okay. So line 65 times 2 pi. So animation.value times math. Yes, times math.pi times 2. Or maybe not. Sorry. I thought I'm already importing math there, but maybe not. All right.
Man, I'm not used to this big of font and only half my screen.
Yeah.
Okay.
So we're just basically saying like go all 360 degrees, right? Yep.
Wow.
So I still,
that is a thing.
yeah.
It's rotating.
I wonder why we still don't see a lot of like perspective, but I know it's beautiful, Verdi. I know it's the most beautiful thing I've ever seen, actually.
Yeah,
So
this is high quality graphics.
yeah. So we could just call it a day, to be honest. But I think I would like to see more perspective somehow.
Yeah.
And also we could try another object, but I'm not sure.
You want to try it? Let's try an actual pyramid. That'd be fun.
Yeah.
So we got to go to where the points are defined, which was in main, right?
I think so. Or
Let's do a
maybe
pyramid with the top cut off. So you've got, this would be the correct base, and then we just need to bring these points in, right?
yes. So just put I think it would be something like 0.5, 0.5, 1 or something. Instead of the 4 points at the top, we need to.
Oh yeah, I'm trying to visualize actually what's even what here. So X was left, right. Y is
Oh,
top.
that's right. Yes. So you actually want the base of the pyramid to be at the base, which makes sense.
Right. So that would be that's basically, I'm thinking the bottom 4 points would be the base.
Yes.
And I want to reorganize. I'm going to reorder these so that
So
those ones
if
are the
y
base.
y is up, so therefore I think yeah, put all the y's together. Where
You want don't we want the ones where Z is 0? Aren't these? These are now the bottom, right?
okay, I thought that for us y was
No, Z is
up.
depth. You're
Yeah,
right.
I think so. So put together the ones that are where y is 0, and then
Yes.
just
Yeah.
comment out the rest and put
And that'll
instead of
confirm.
there. Yep. And now
Smart.
if oh
Not what we
okay.
expected.
Yeah, but that's fine. I mean, I'm not even sure how we're rotating the camera, to be
Oh,
honest.
no one is. No one
Yeah,
is.
yes.
No one knows.
But okay, yeah. I kind of want to create like a ball in space, but that's probably more work.
Well, if you know how to do it, I'm certainly open to it.
Right. I would just go like create a small Dart function that just outputs a lot. I mean, no, let's not do it. That's gonna be too much. Yeah, I think this is fine. I just want to play around with. Oh yeah. Okay,
This is not
so
what I was expecting. So X is
okay,
is top down. Maybe because of our camera rotation?
maybe. Anyway, that's fine. Just put a little top thing there. You know.
All right, so
So
we want, these are
just
all
want.
going to be higher. So
Oh, what are you trying to do? I thought like we would just have a pyramid with 1 point, but you probably think like with.
oh, we could do just one. Well, 1 point where we won't see anything.
Yeah,
Right.
true.
Well, actually, let's confirm that because we've been wrong about a lot of things. So this would be
1.
0.5.
I
Oh
think
yeah,
it would
this
be
would be
1,
1 and then 0.5.
0.5, 0.5, I
Yeah,
think.
yeah.
Let's see. Yep.
Wonderful.
Ah.
Gosh, never in doubt. Never in doubt. So now if we want 4 points, they would all have this same height. And then we could go like 0.4. Would we just go kind of 0.4, 0.4, 0.6, 0.4, 0.4, 0.6, and 6.6.
I have no idea what you're doing.
Does that make any sense?
No, it doesn't.
Ah,
Oh, nice.
check me out.
Nice.
Yeah. We got a pyramid here. Now, how else could we move this?
So, Craig, some people are getting motion sickness. I'm pretty sure this is just fun, but I would, if I were you, I would change the second one to something like second 10. The animation speed.
Okay. I don't remember
wherever that is. Yeah, me
There we
neither.
go.
Yeah, and yeah,
There we
nice. Okay,
go.
nice, right?
That's satisfying.
Yeah. Anyway, so do you want to see if we can? I still don't understand why we don't see any, perspective. I mean, we probably do.
I feel like we are seeing perspective. Why we didn't before the animation, I also don't know. But I mean, wait, are we? No, we're not. No, you're right. We're not.
Yeah, I don't think we do.
Because the points should never both be over each other. Like there's a right now, right? Or right now at the top.
Yeah.
Both of them line up, but when
they
it's
should be like
perfectly
this.
centered, the back one should be centered.
Like this. Yes.
Okay, so we don't
I
have
don't know
perspective yet.
why. So one thing that I see, I don't see it actually used in the code that I've seen and the code that I'm using. So I don't know why, but apart from make view matrix, there's also make perspective matrix.
Oh.
And again, I think we could theoretically just check it out, or even multiply it with what we already have. What?
That's so funny and just 1,000,000,000% true. Oh gosh, that's incredible. All right, what are you thinking about the perspective matrix?
So just like do another, instead of view or next to the view matrix, create a perspective matrix. So final perspective matrix. And equals make perspective. Yes. And now
oh boy.
So FOV Y radians we actually know how to do. So that's the field of view. Yeah, we already have it.
Yeah, we just value to radians.
Yes. So
what's the radians conversion? Just
radians. So radians 60 or whatever. Oh yeah. You're up. Yeah. Oh, good point.
Implicit. I guess we'll put it all the way at the bottom.
Yep.
Okay. Z near. This looks like it's maybe near.
Yeah, just near and far. And now I don't know if this goes instead of or all, like try to. Yeah. Yep. Let's see. Exactly. Just exactly like, oh.
Okay.
What?
Unexpected. Wait, no, expected, because we just removed where we're using the rotation.
Yes, makes sense. So instead of,
should we put the rotation into one of these?
Oh no. So in line 42, focus, right?
Yep.
Line 42, I think you want either both of them, or instead of projection matrix, do the perspective matrix. Yep, and now try it. Is it better?
Nope.
No, it's not.
No change.
No,
which is a real surprise, or at least no change that I can work out.
Yeah.
Now, the other thought was that we might need all three, but
All
order
three.
matters. So
It
what
does.
order would
Yes.
we
I don't know. I
try?
have no idea. I've never.
There's
Yep.
only so many possibilities.
Yes.
Okay, this one does nothing. This one does nothing.
Mm-hmm.
And this one breaks everything.
Oh, I love it. I love it. We're inventing new 3D ways to look at. Whoa, it's like a carousel. Like, hello.
Yeah. But when it comes back the other way, we only see, I wonder, gosh, I want to know where the top 4 are. Oh, I think they're just clipped off the top. Yeah, maybe. I think they're just clipped off the top. So how would
But
we do
I
this?
can see a little bit of, do you also see kind of almost like a perspective there? Or is it just my imagination?
No, I think you might be right. I want to see the top ones when they come back. So we just worked out that X for some reason is top down. Actually, I have no idea which of these is going to do it, but which of these lowers the whole thing?
Okay. So I think we're like, this is like literally broken. I don't think this is what it should work out, and no amount of tweaking will make it correct. But I think some of it, maybe it's just that we're looking at such a small thing with such, I don't know. I have no idea.
Roa thinks there's perspective.
Yes, there is. Yeah. But I think it's like inverse perspective. So that's not good.
Inverse perspective? What does that mean?
I mean, like, it looks like to me that.
Wait, I screwed this up. Now that I'm full screen here, I can see I've got projection after view. That was never it.
Okay. Yep.
I copied the wrong one. We wanted to try this order. And if you restart, then we get
weirdness.
Kind of the same thing.
Yes.
Definitely very similar. So this was adding projection in the we added perspective at the end. That's what we did.
Yeah, I think like we are using two things, and both of them has FOV and near and far. So I'm pretty sure only one of them
they're
is
just trampling over each other.
Yeah. So maybe, I don't know. How do we? Hey! Isn't it? If you look at the base, doesn't it look like?
No.
No, really?
No.
They're moved. Okay.
So we're gonna add. I'm gonna. Because it's easier for me to see than anyone else, because I get all the frames per second.
Right.
So we're going to add, what's the easiest way to do this? In View 3D, I'm going to add, where's our stateful widget? You are this, nope. One day I'll find the stateful widget. The code's too big. Here we are. Great. Let's add a wrap-in widget, gesture detector on tap. And this is going to be a stop animation. And stop animation is going to do controller.stop. There we go.
Ah, clever.
And now you have to put focus on the window, and then I'll tap when they're right up. No, didn't work. Tap. Oh, no, I shouldn't have to call set state. What am I doing? Why isn't this working?
No. That should work. Where's the gesture? Oh yeah.
It's around the whole.
Oh, you know what? You should probably call the stop animation. You're only returning it.
You're right.
Yep.
Okay, focus on the thing. Oh no, it stopped already. Okay. Yeah. It took a second. but I think we can see that they're all kind of equidistant here.
All right. So my next thing to try is have a look back to project. Yep. Everyone was correct, except for Craig.
Gosh, that's story of my life.
Yeah, mine too. All right, so I think you tweaked the frustum a little bit, and I wonder if, for example, the far, if you can just put instead of it's 1000. That's not too bad. Was there something that we? Yeah, you were right.
Near, the only thing we've changed actually is
fine.
near. Originally it was this, but should be the same.
Yeah, it should be the same. Aspect ratio. By the way, aspect ratio we could still fix, but I think that's not what's our problem.
Nope.
Let's do. Can you just make FOV something like 120 degrees? I think that's. It should
Mad
be
about something. Okay, all the files are saved. Oh no, we do have some red here. What did I do? Command Z. What did I do?
Near. You made near into an int. Yeah. 0.50. I think it's or whatever. Yes.
All right. So same. Here we can see the lack of perspective.
Taunting us.
Mm-hmm.
Damn. I have no idea.
Yeah. I don't think I know it. Well, no, I know I don't know. I'm quite certain that I have no idea.
We're not. Oh, yeah, we're not. Wait, perspective matrix. We're not using it. That's good.
Yeah, because using it did absolutely nothing.
Absolutely nothing.
Same again.
Yeah.
Oh, my. There we go. Apparently, I just can't click good.
Does anyone in the chat have ideas on how to fix this? Because we're
pretty desperate.
Yes. Did you transform the camera? I don't know what that means.
In a way, yes, it's rotating. We transformed its position. That's the first parameter here. Is there anything else you think they might have meant, Philip?
Oh, do you want to put it closer? Like we're 10 units. I still think maybe there's some perspective there. So instead of 10, vector 3 times 10, put it like 5 or maybe 2. Yeah. We're really close to the what? Yeah, nothing.
No, it's different.
Is it?
It's tilting. It is tilting. So like now it's kind of flat and now it's almost tilting down a little bit. And now it's getting a little more flat, right? Because the dots are clipping each other on the top. And then in a second, now they're not clipping each other on the top.
Oh.
Yeah, base as well for sure. Just a little more obvious to me on the top, but I'm sure they're doing the same thing.
So that interesting. So now, this would be when if we didn't have just dots but instead have faces, we would probably know what's
right.
Because right now, like I'm not even sure if we're looking from a little bit below or from a little bit above.
Oh yeah, and chat it keeps being like connect the dots, but I feel like we are out of time for that.
Yes. But by the way, the code is in GitHub, and anyone is very much. It's public, so everyone is very much invited to prove us terrible.
Actually, that would be amazing. Anyone who I'm going to add the GitHub link to this. I'll show it to everyone. I would love to be tagged on Twitter with the change that makes this do what we want. I need to make a banner, I think, for this. There we go. Paste in the value, add the banner. All right, so this is where Filip put the starter code. Oh, I should commit the changes that we've made today, huh?
Mm-hmm.
That would probably be helpful for everyone. All right, I'm going to make things smaller. I don't even know how to. It's hard to look at this. All right, I'll just commit everything. And Filip painstakingly telling me what to type.
Oh, yeah. You just, yeah, okay. Avoiding the blame, I see.
I forgot that I went through that with not even sharing my screen, but yeah, that's our commit message. So I'll even just kind of load that up myself and bring it in. Did that commit go through? There was 3 commits before. There's still only 3 commits. Did it? Oh, Filip.
Oh, you didn't fork it. Okay, I'll give you, since it's you, and okay, I'll give you access to my repo, FLIP. What's it called? Observable Flutter Cube.
Flutter Cube, yeah.
And then collaborators. Ugh. 2-factor authentication. Sorry, people.
I understand that like hackers honestly just ruin everything. I understand that they're going to steal our identity and like buy themselves trips to Cancun on our credit cards and everything. I just freaking hate how often I am logged out of everything. Oh my God. I am so tired of it.
Yep. Me too. Craig, what's your username? Or you can just send it if it's...
It's just my name, Craig Labenz. I have a real deep cover alias.
Yes, that's you, and you are invited, sir.
Brilliant.
All right, I'll give you the link.
Oh, I'm probably gonna have to do the same headache to accept the invite.
Yes. You'll have to call with your passports to someone, and they'll be like, "Are you sure you're Craig?"
Dental records.
Yeah.
Okay, so I just accepted. So now I'm gonna push this commit again. Git push. There we are. All right. So if I refresh here, we will see.
We still don't see. We don't see your. I guess yes.
Yeah, I got rid of it because I thought I might have to 2-factor or something.
Yeah, true.
But there we are. Okay, so today's chicken scratches are available for y'all to dissect and fix because they're kind of broken. But man, Filip, thank you for 2 hours of your time. Gosh, I had a blast today. That was very fun. I still don't know any linear algebra, but
maybe that. But yeah, I'm really like looking forward to do it one time again because this was fun. I think people in the comments also had fun. Hi everyone, by the way. I see your comments. I can say hi to everyone there. But it's fantastic. It's great to once in a while pop back and just fail in real time while being watched by people I know.
You invented failing in real time. That was
thank you. This will be on my tombstone.
Inventor of failure. Oh man. Okay, yeah, gosh. Well, needless to say, you've got a kid. This is in the evening for you, so I don't want to be presumptuous about your time, but you hit me up anytime you want to come here and not know what we're doing while people are watching. I had a blast.
Me too. Cool.
Standing invite. Okay, folks. Man, This was incredible. I think I'm off next week because I have my first improv show in the evening. And so I just need to be in the office. And so I'm not going to stream in the morning, blah, blah, blah.
Are you doing improv? Like, is that like you're actually doing
Yeah,
improv
yeah.
theater? Nice.
Yeah, it's
Wow.
it's a Flutter DevRel'er tradition. There's always got to be at least one improviser on the team.
True.
And when
Yeah.
Emily left, the torch went a little cold. But yeah, anyway, so next week off, and then we'll be back. And then there's the American holiday, Thanksgiving. That's on a Thursday for some reason. So I'll definitely be off that day. And then we'll finish the year strong. So I don't know how many weeks we got left and whatnot. But off next week, then back. Filip, this was amazing. Any closing thoughts on your end?
I think we did a fantastic job. I think we need 2 or 3 more commits, and Unreal is shaking in fear. Unreal Unity, you're going down. This is, we're going to figure out the projection matrix at some point, and then it's over for you. Okay.
We're so close. I'm so close. Oh gosh, that's incredibly funny. Okay. Have a good one, everybody. See ya.